Hi, welcome to this new video tutorial. I'm going to create in this video a custom object detector which detects a koala. But of course you can choose your own object. We will see this in 3 steps. First, we're going to see how to prepare the images to be trained with YOLO. Second, we're going to upload all these images online on the Google server so that they can be processed for the training. So you don't need a powerful computer or GPU because all the processing will be done online using the Google Cloud GPU for free. More detail about Google Collab and Google Cloud GPU for free, I will give them in the second step. And finally, after we have set up Google Collab and train our model, we will test our model to see if it really works well. This is all for the moment. Let's start. First of all, let's prepare the image dataset. The image dataset is going to contain a lot of images where it is the object that you want to train. So for example, here I choose a koala and I downloaded around 350 images of koalas. You can see them here. So you have to download many images of your own object. The more you have, the better. I will suggest to have at least as a minimum of 100 images. And if you have 400 or 500 is even better. So for example, let's see the example of the images I have. So here is the koala. Here is also the koala. And it's important that there is your object inside, but it doesn't matter if it doesn't take all the image. For example, here I have a big image, but the koala is really small. And also you can have more objects. So you can have a koala, there can be other objects that you are not interested in, because later we are going to select where is our object. So if I go on, this is an example of dataset. So here, for example, we have 2 koalas, 1 and 2, and we're going to select them all. Our goal, once we have the image dataset, is also to tell in which exact position is our object. We cannot just give the images and say nothing else. We give the images. So for example, here we have 2 koalas, and this koala is placed in this position, first koala, and the second is placed in this other position. To do this, we are going to use a software which will make this operation really simple for us. And we have a free software which is called Label EMG and is available for Windows, Linux and Mac also. Here you don't see the Mac, but it's also for Mac. I will put the link on the blog in case you have the Mac. Now, as I'm using Windows, I will go with the one for Windows and we're going to download the software. And then we can open the software. So Windows and then Label EMG. Let's run this one. Now, here is the software. We're going to use the software to select our objects in all the image dataset. So first of all, we have to open the directory where we have our images. And this is my directory, so I'm going to copy this. Then I go to open directory. You can of course look for the directory on your computer. I will just copy here the path and open this directory, and then I press on select folder. Once this is done, we have to set something else on the software. Then, for example, where we want to save our files, and we put the same directory where are our images, and we select the folder. Then we change here the format. We have 2 formats. We have Pascal and then we have YOLO. As we're going to train YOLO right now, we want to save them in the YOLO format. Once we have done these first operations, is the time for us to select our object. So I press on create rect box and we can start selecting our object. And I'm going to select the koala for all the images that I have. So I start with the first one. The label is a koala. And okay. Then we save this and we go to the next image. This one. Okay, I didn't know I had this one on the dataset. Anyway, it's still a koala. Second image. Okay, save this. Then this one, this one is really chill on the tree. Create rect box and then koala and save. Next. And we do this for all the images that we have. So I'm going to pause the video. I will do this for all the 300 plus images I have, and then I will be back. And here we are again. After you are done with the selection, your dataset will look like this. We have the JPG image and then we have a TXT file with the same name associated. So if I open this file, here is simply telling us the position of the koala on the correspondent image. So for example, 0 is the class. We have only one class, so we're going to work only with one custom object. Then we have the center X of the koala, the center Y of the koala. So the image is 0 to 1. So at 0.4 there is the center Y, 0.46 there is the opposite, 0.40 there is the center X, 0.46 the center Y. Here is the width and then the height. And the software that we use to select our custom object does this for us. So you don't really have to know what's inside. I wanted just to show you how this works. Then on the folder where we have all of them, we do one simple operation. We select them all. I press Ctrl A and we're going to put them into a zip archive. So add to archive and then a zip format, and let's call this one images.zip. And please remember, use the same names I'm using. So images.zip must be images.zip and not any other name. So not koala.zip or something else. And the reason why is because I prepared the code that later will look for images.zip. So if this is of different name, it will not work. So keep that in mind. So I created images.zip, which should be now at the end of the file. So here, images.zip. And so if I open this, it will look like this. We have the image JPG and then associated we have the TXT file for all our images. And at the end of this operation, our dataset is ready. So we can now switch to the other part of this tutorial where we will see how to use this dataset to be trained for our custom object detector. Once our dataset is ready, so once we have the archive images.zip with the images inside in the TXT file with the position of our custom object, we can now switch on to Google Colab. Google Collab is a service offered by Google, so they give you ready to use a free GPU, they give you a Python editor and Ubuntu already installed, ready for the use. And if you are wondering about what GPU do you get, so free access to GPUs, if we go on Google Cloud GPUs and we check here accelerated computing, here we can read deep learning, physical simulation and molecular modeling are accelerated with NVIDIA Tesla K80, P4, T4, P100 and V100 GPUs. you are getting some of these GPUs. Each time you connect to the Collab, you will get a different settings. Most of the time you will get the Tesla K80, which is the cheapest one, but still a really decent GPU. So the range of the cost, they go from 1,000 euro, the Tesla K80, which should have around 12 gigabyte of RAM or 24 gigabyte of RAM, because you get half of the GPU for this one. Then increasing, we have the P44, P100, which is around 5,000 plus euro, and then the V100, which is 20,000 plus euro. Most of the time you will get Tesla K80. Sometimes I got the P100, so they are really great GPUs to use. What are the advantages of Google Colab and the disadvantages? Of course, advantages that you get a free GPU, which is really expensive, so you can just work with your laptop. And a disadvantage that you have access only for 12 hours. After 12 hours, you get disconnected and you lose all your files. You can use again Google Colab, but you have to start everything from scratch. We can solve somehow this problem connecting our Google Colab with Google Drive. So we're going to save the file on our Google Drive, so that even if the Collab get disconnected, we will still have our files on Google Drive. Let's start from Google Drive. So you go on google.com/drive, then go to Google Drive. If you have an account, you are going to log in. If not, just make your account. I have an account, so I'm just going to log in. I enter the password. And here it's my drive. It's in Italian. I don't know how to change the language, so for this part it will be Italian. We're going to create a new folder, and I call this YOLO v3, and just follow what I'm doing exactly. So create the same folder, because my notebook, which will do all the work, is made in order to work with this specific folder. So just call this YOLO v3, all lowercase letters, and inside YOLO v3, so we enter in the folder, we're going to put our images.zip file. So I take this one, and images.zip, it is going to be here inside. And let's wait that the upload finishes, and then we can continue. I'm going to pause the video waiting for the upload. Okay, now the file images.zip has been uploaded, and in the meantime I was also able to switch the language with English. Now we have my drive, and then we have a folder YOLO v3, which, keep in mind, must be YOLO v3 capital letters, and inside images.zip. Inside images.zip you need to have the images.jpg and the txt file. Now let's go on Google Colab. So collab.research.google.com, and then sign in, and we need to use the same account we used to log in on Google Drive. And here we're going to upload a notebook. So upload, and this notebook is on my blog, so you can download the notebook and then you can upload it. And I have it right here. So here I downloaded the notebook, and then I upload this notebook. And here we have the file. So let's do the first steps. First, we need to enable the GPU on Google Colab. So we go on Edit, Notebook Settings, Then runtime Python 3, this is by default, and then hardware accelerator, you select GPU, and then we press save. Now to make sure that our GPU is enabled, we go on the first code box and we press start. So NVIDIA SMI, this one, and it takes a few seconds. So now it's connecting and initializing the notebook. And here we see our configuration of the GPU. Now I got the Tesla P4, so here is the GPU that you got. Here is the memory. It's 8 GB of memory of RAM. And here is the RAM that you're using, still 0 because we're not using it. Here the percentage of usage, we're not using it yet. Then second step, we need to connect our Google Colab with our Google Drive. So we go on the second box and we press run. Now it is asking to our permission to access to Google Colab, so we need to go to this URL accounts.google to give the permission. So we select our account and we are going to allow Google Colab for Google file stream, and we select allow. And here is the code that we need to copy. So we click here to copy the code. Then we go back on our Google Colab, and here it asks for authorization code, and we can paste here the code, and then let's press enter. Okay, our drive has been mounted, so we see Collab notebooks and YOLO v3, which is the folder that we created before. From now on, we don't have to do anything anymore for our training because all the code is written here. So what we do, we just go on runtime and then run all. And I will explain step by step. Now it is downloading the Darknet. Darknet is the framework which we use to train YOLO. Once we download the Darknet, we need to compile the Darknet in order to work with the GPU. So here what I did, I changed the settings to enable OpenCV. So OpenCV is enabled, the GPU is enabled, and also CUDNN, which is a configuration of the NVIDIA GPUs, is enabled. And now this step is still in progress. When we see this, it means that it is still doing the compiling of the Darknet with the NVIDIA GPU. And we can go down to see slowly the next steps. After the Darknet has been compiled, we can see we have to configure the Darknet to work with YOLO v3 for the training, and here is what the code after is for. So here we are configuring the YOLO v3 file to work with just one class. So keep in mind that all this will work with just one class. So for example, only one single object. To work with more objects, you need to change a few settings, so that's not the case for this. Keep in mind, choose only one object. And so all this code is for the configuration. Then we go to the number 4. Number 4 is going to extract the images that we put on images.zip, and is going to put the images into the Darknet so that these images can be processed later. These images will be inside the Darknet folder, and then we're going to create, it is automatic in this section of the code. It is going to take all the list of the images and putting all the names of the path on the train txt which is all the images that our custom detector is going to use for the training. So we're going to use them all. This is probably the slowest step when it is downloading now the model, the starting model that we're going to use to train YOLO v3. This is really slow. You see just 5% because the connection of the website where there is this file is quite slow. So I'm going to pause the video until this file is downloaded. I left this running for around 3 hours already. And if we check our current situation, 1385 iterations and average loss 0.15. It's of course better if you leave it as long as it is necessary, so even a few more hours, but already some really low value of average loss can be a reliable result for our testing. So I'm not going to test it to train it even further because it's not necessary, but if you have the chance, keep and leave it going as it is. So I'm going to stop the training right now. And as we're waiting that we stop the training, we can see 1389 iterations, average loss 0.14. Now it's the moment for testing the model. So where is our model? Well, our model, we can find it easily on our drive. So we go back on our Google Drive, so my drive, YOLO version 3. We open this and we see now 2 files, new. YOLO v3 training 1000 and YOLO v3 training last weights. This is our model. This is the last model that we got, and this was the model after 1000 iterations. So most likely your model will be at its best after and the last training, so after all the iterations. So what you should be supposed to use is this one, which updates the iteration each 100. So this one was after 1300 iterations. And of course you get also the backup for each 1000 iterations of the training. So you get 1000, 2000 and so on. We just need this one. So if you don't want, you can remove that one. You can also try all of them to see which one works best. So I'm now going to download this one, YOLO v3 training, and I'm going to put this one on a new project where we're going to run YOLO from the computer with OpenCV. So I downloaded already a few of them, so I will just change the name. I will call this with the number 3 after. And as I'm waiting that this downloads, I'm going to explain how we can train the new object detector. So I'm going to open the new project. I developed this code to load a lot of images so that we can test it in real time with many images. This code is a small adaptation of the code I released on my tutorial on YouTube regarding detecting object with YOLO and OpenCV. So let's check how to use this code. I'm going to increase the size so that everyone can see it. We have only to edit these 3 lines, and all the rest you have to leave it as it is. So all this is the detection using the YOLO algorithm and OpenCV. And on the first line we have to load our train model. So we have to load the weights that I'm just downloading right now that we got. YOLO v3 testing CFG, this one I'm going to put it as it is, so you can download this one with the code. So CFG is already on the file. The classes, here you have to put the name of your class. So I detected Koala, so I will put Koala. If you detected another object, you can put the name of the object you detected. And this is going to work with only one class. So you cannot put more classes, just one class. This images path, here we're going to put the path where our images are located so that we can test our model. So the same folder that we had before with our images, we can use it now for testing our model. So I'm going to copy this path, copy, and I'm going to put the path right here, and this way. So it is going to take all the images which are inside the folder, and that's all. So I'm waiting that the model is downloaded. So I'm going to check if it's already downloaded. So here we have already the model. YOLO v3 training last 3. So most likely you will have just YOLO v3 training last. I downloaded them also before, so that's why I call it with number 3. And let's test it. So I run this one. So Koala on the first image is detected correctly. Let's go on. Koala, Koala. Well, this one didn't work. You can see that except in just one of them, it works in general really well with the detection. And of course, if I left it training a few more hours, it will work even better. So even probably the one that wasn't able to detect, it could be detected with a better model. But already after just 3 hours of training, you can see that we were able to build a model. Okay, this one really small, cannot see the koala. So I think this is enough. You can find more detailed instructions and this code that I've just used to test our model on my blog, so you can just click the link below on the description. This is all for this tutorial. Hope you enjoyed and see you in the next video.